Koo, what's up?
Hey Joe, thanks. Hi, good morning
Hey,
here from Singapore.
all right. Well, good evening here from the America. Um, yeah, glad to finally meet you. Seems like we
Yes,
are kind of long lost brothers on LinkedIn.
looks like
It's
it.
just, yeah, it's a small world. So,
Yeah, there is. I mean, given what's happening now and all right. So a lot of us are spending time on LinkedIn, on Facebook, and all this. And I kind of think that at least for me, I found a few long lost brothers in terms of data science, in terms of artificial intelligence, and all. And I think especially I think the both of us only just met recently, probably on LinkedIn. I think it's about maybe 1 or 2 months ago. And then we kind of like hit it off. We have a lot to chat and all this.
yeah. I think it was a couple months ago. I think we met because you were calling me out on this article I posted about of the Wall Street Journal, and you're like, that that doesn't seem right. And so we started chatting more about that. That I think we realized, I think we take very I would say I would hate to use the word contrarian views, but I
Mhm.
would say something similar to that with respect to data and
Uh,
data science. And I know that you've spoken a lot on data myths, as well as had some recent posts on that. What got you thinking about data myths?
okay, so I run a data science meetup group here in Singapore, together with a few friends, not my own individual effort. And what happens is, I think over here in Singapore, we have a lot of myths ongoing and all. And I was putting all these like myths out there on my LinkedIn, right, just to see how is it like around the world as well. I mean the data that I collected, put it in data science terms, right? The data that I collected, right, are mostly Singapore data, and it doesn't mean that Singapore data is representative of the whole world. And LinkedIn is sort of like a window for me to like see how is it like across the world. And apparently, it seems that it resonates with a lot of folks. Um, the other thing is also I wanted to bust this myth. Reason being is that from what I sense is this myth has created a lot of frustration for the professionals. I think I was just talking to Danny yesterday. Danny, which is another friend of ours, mutual friend of ours on LinkedIn. And we were talking about this myths going around, frustrating the different people, especially like there's one myth that says, so recently I posted that on LinkedIn, and the myth is the more complicated the model, the better the better it
Oh,
is.
yeah.
So forget about all the simple models and all. And apparently, I think a lot of people can identify with that. It seems, given the amount of interaction and all from the people. Yeah. So yes, I,
Yeah.
I, I kind of like want to remove this frustration for everyone here that's working in the data science industry, like put it that way. Yeah.
Yeah, it seems like the kind of the group we've somehow assembled. It's interesting seeing the opinions around complications in, I guess, complexity in data science and data in general, right? So I know that my moniker is recovering data scientist because I've just seen like too many data science projects start and without building a solid foundation of like infrastructure or
Mm.
like having a plan, um, like basic stuff, right? So let's just jump in and start throwing machine learning at the problem. Like that tends to be, what I think what a lot of us have seen. And then not only just machine learning, but so deep learning out of the box too, because why not?
Mm.
And so it's yeah, your post was interesting. I think some of the comments were interesting too, and also like, as you point out, the fact that people from around the globe have seen very similar things. So I think it's both refreshing and scary. It would be great if it was confined only to Singapore, because at least then it would you could deal with it. But it's not. So
No, I guess it's not a regional issue. It's more of a humanity issue rather.
mhm.
Yes, I guess it's more of like um we it's more like humans always are trying to seek a straight through process, a guidelines and all this. But I think I guess when it comes to data science, it's not so straightforward these days. One of the myth that people usually have, right, is that they thought that data science is like a straight through process, right? You just have to follow the stages and all.
Right.
But I tell the folks, I say that fortunately and unfortunately, so unfortunately it's not that straightforward. Yes, there is a 1 to 9 step which I listed down, but unfortunately it's not so straightforward because each stage has its like unique challenges and all, right? I mean we work in data science, right? Why we are always looking forward to different data science project is because of the unique challenges, even though we still follow that straight through process. So when participants in my training course, they ask me that, hey, cool, do you have like a straight through process? And these are the steps I follow. I tell them, I said, unfortunately, no, if you're looking at that. But I will tell you the fortunate part is what? The fortunate part is at least AI won't replace you. I mean, if you look at how AI works these days, right, is smarter automation. And if you look at the word automation, it means what? It means that it has to be a well-defined steps so that it can get automated. Yeah, right. Yeah. So the good news is we won't get replaced. Although I know there's another myth swirling around and says that AI is going to replace data scientists. And we just have to wait for AI to get so smart, right, until we can replace data scientists. And then, yeah, you data scientists are expensive buggers.
It was interesting, actually. I was talking to this student in Australia today about that, and I think on one hand there is, I think auto ML will probably replace some aspects of what a data scientist does, but I would say it frees up the data scientist to do the science part of data science. Right now, throwing algorithms out of data, for example, it's kind of like that's one approach, but it's also really like naive and dumb approach, right? Because I mean, I know I've worked in auto ML on and off for a long time now, and the realization I had even back in the day was it's like, these algorithms they're just math, and it's just pattern recognition. So like, and the hardest part is actually making the data set that you're going to feed in to the algorithm, and like that, if you can't get that right, it really doesn't matter if you're applying simple algorithms or deep learning or anything in between, because the results are going to be kind of crap. It's not like the algorithms like will fix the issues underlying your data. It just doesn't really work that way. So
you're right. You're right. I agree with that. So that's why so anyone who asked me about joining boot camps and all, right, then I just told them that says that, yeah, you can join. I mean, okay, nothing wrong with joining boot camps. I just want to say that.
Yeah.
But boot camps, I think if you look at most of the syllabus, right, what they do is they cover a lot of machine learning. Yeah. So here's the funny part, right? You realize that, hey, I'm covering a lot of machine learning in boot camps, and then there's this opposite of the camp which says that there's auto ML that's coming in to replace that particular part. And we professionals, we already mentioned and says that actually ML is just a very small part. It's just a very small part of it. There's also the bigger part, and just like what you mentioned about structuring the data. And structuring the data itself is, again, it's not a straight through process. It's not like you take step 1 to step 10 and then you get the data that you need.
Right.
We know it's not that straightforward, right? Then there's this discussion about getting tidy data. There's this discussion about, hey, does this data set, do I have to turn it into a wide form? Do I have to turn it into a narrow form? So for those of you, for the listener, for the audience who don't know about it, probably these are keywords that you want to Google and find out a bit more. And yeah, it's just that there are all these different statements that probably a single person could have heard all of them, right? But if they have maybe like a jigsaw puzzle, right? They put all these different points together, they would have seen a clearer picture, right? A clearer picture of it. Yeah, I would say, if you ask me, right, I probably would like to do a lot more projects rather. I mean, yes, there's a place for theory, but I think there's also a time to stop, right? A time to stop. I mean, you keep on doing theory and all this, but there's a time to stop, and then you probably just really have to go in and get your hands dirty.
Yeah, like I saw the student today, I think like because he is a math, he's doing his undergrad in math and is going to be graduating next year, and he's like, so how do I stand out? You know, and what is a really crowded field right now of data scientists. You have people coming out of boot camps, universities, and everywhere else in between. And I was like, you know, you really, I think the thing you got to focus on is figuring out like what problems really fascinate you, and like if you weren't getting paid money to solve this problem, like what would you want to do anyway, just because it would be awesome to do. And then, you know, focus in that direction. That also means like as you try and solve that problem, you're going to pick up the techniques that you need to solve that problem. And I think that's usually the best way to learn. Like the materials taught in boot camps, I mean, I think it's a good starting point for at least understanding the sort of the mechanics of machine learning and visualizations and you know, and analytics and that sort of thing. But you really got to start applying it though, right? And I think only through doing that do you understand what tools are really going to be useful. Like in the class, you know, the people I either mentor or maybe not so much a class I recently taught, but I think in other things that projects I've overseen for students, especially learning machine learning, like they just want to go out and just do it. Like let's do machine learning on everything, you know, like any problem, you know, summing two numbers together. Let's use deep learning for that because that's like
Yeah.
obviously the, you know, a really good use. So there's a lot of enthusiasm, but I would say like as you get into your career, the interesting things and things I like about what you're posting too is it's this drive back towards being simple and not complicating things and trying to figure out, okay, what is like the laziest approach I can take to solve this problem? Maybe I am thinking about it wrong, right? Or maybe this problem doesn't need to be solved. Maybe we're asking the wrong question actually, you know? And
Yeah.
I think part of what you're hinting at is, you know, as you progress, it's one thing to learn the mechanics and have this toolkit that you're going to get, you know, with machine learning formulas and all this stuff, but learning how to ask good questions and learning how to identify problems, to me, that's like the skill that just in general in business that you need to get really good at, but particularly when you have a very powerful arsenal at your disposal, like machine learning, you really need to be good at dissecting problems and knowing what to use and what to avoid. So.
Yeah, so to that, right, I think it's also, so for most of the boot camps that I've seen, right, I think what happens is they have boxed these beginners, right? They have boxed these beginners in terms of a certain thinking. So example would be like, for instance, they say that, hey, let's have a model to do credit risk assessment, right? To see whether a person is going to default or not default. So that's a classification problem. But actually, if you look at it, right, from the bank's perspective, we don't stop at that. We don't stop at that when it comes to credit risk management. We, besides classifying whether a person is going to default or not, right, we also have to think about like the probability. That's one. Second thing is also about how much credit to give. Let's say if you really do want to approve. Now you can't have a single model that does both the question, right? You can't have that. It's not well. At least I haven't come across such a model that can do both at the same time. So, but what happens is in the boot camps, right? They always they give you, well, most of the boot camp, what I realize is they give you, hey, this is a problem, this is a model, this is a problem, this is a model, and I kind of find it that if you don't stress during the boot camps, you tell people that, hey, that's not really the case in the real world. What's going to happen is a lot of these participants, a lot of these trainees come out graduating from it, right? They'll think that, hey, I just have to find a model that can solve everything, which we know is not true, right? Which we know is not true. And what's more important is like what you mentioned, right? Is asking the right question and dissecting that question in maybe into smaller questions. And each of these smaller questions, we have like maybe a model that can answer all these now the challenge comes in once you switch to that mindset, right? The next question will be, how do you mesh them together so that you have a final decision, right? You have a final decision. So unfortunately, I kind of feel that was one of the blind spot for most of the training that I've come across, where yeah, one question, one model, one question, one model.
Mm-hmm.
Yeah, and I to be honest, I don't believe in that, and I agree with you. I think being able to know how to ask the right questions and dissecting the question is more important. If one wants to be in this particular field itself, yeah.
Yeah, it almost seems like data scientists would benefit from like studying techniques used by journalists,
Mm.
like an investigative journalist, for example,
Mm.
right? Like you're
Mm.
asking
Mm.
like who, what, where, when, how. Because when you think about these things, I mean, it's the same approach that you actually use when you're using like um, agile data modeling for like data warehouses. You can take one approach and take a very rigid approach, which is typically how models are approached in data science land. And but the flexibility, I think, of diving deeper into things like the who, what, where, when, why, and how, and so forth, is that starts exposing, okay, so like what data is actually going to be useful to answer this question, right? And because all too often, especially junior data scientists, when they talk about how they're going to solve a problem, it's not so much, well, what is a problem we're going to try and solve? Usually the first answer is, oh, well, let's use XGBoost or something. Like, it's like, well, you don't even know what you're trying to do
Yeah,
yet. But it's like, well, I don't need to. We just use XGBoost. So it's
achievers.
like
Yeah.
all the way. And it's a great algorithm, but maybe you don't need to use it. So
I I guess the SG boosting came about was because of Kaggle.
mhm.
I mean, so probably about 6 or 7 years ago, if I remember correct, no, probably 4 or 5 years ago, when Kaggle was actually quite getting very popular among the machine learning enthusiasts, right? What happened was, I know it slowly sort of evolved into a trend where, hey, let's just XG boost everything.
Yep.
Yeah, let's just XG boost everything. Okay, this problem that we have, right? Don't care about don't need to care about what's the model performance matrix you're going for. Don't need to care about how do we structure the whole modeling process and all this. Let's just do XG boost for everything. Uh, I think that's the one that's the way, that's how the myth came about lah. But I think now XG boost has been taken over by a more complex, I'll put it in quotes, complex model, and that is deep learning.
Yep.
Like what you
Yeah. Now it's
mentioned.
just deep learning everything, right? So
Yeah.
yeah, it's interesting. I mean, some of our business partners, bigger tech companies. I mean, they've taken a deep learning first approach for nearly everything,
Mm-hmm.
and I think it works. Even in the auto ML products. I mean, they're using a lot of deep learning, and I think for their specific thing, they have just so much horsepower they can throw it. I mean, it's like, why not in their case? So, but they
But
also
you
have a
touched
lot of
on a very
data.
interesting.
So,
But you touched on an interesting point just now, which is horsepower. I kind of feel that at least the way I look at the industry, right? If you were to move into deep learning and or what's going to happen is it becomes an arms race. The one that actually has the most computing power will win. I mean that's how deep learning is. That's how deep learning is structured, right? Uh, then was talking about deep learning. So we were so I will share this example. I thought I'll share this example over here. So what happened was, I have a agency, a business organization came to me and says, hey, cool, we would like to engage you. It says that, hey, cool, we'd like to engage you as a consultant and all. But the thing is this: we have this question, right, and we would like to deep learning the out of it. Okay. So I was thinking in my mind, I said that why is that the case? Because the particular problem, right, the way I look at it, I think a simple moving average will have probably answered the question much better, much better. So I told the potential client, I said that why would you want to directly dictate what's the tools to use to solve the problem? and not the other way around and says that let's look at the problem and see whether there's a simpler way to do it. So what happened was the person explained to me and says that, oh, the reason was because the top management had heard about this thing called deep learning, and deep learning to them is equivalent to AI. So they want to like do deep learning so that they can tell people that I'm doing AI. So it's, if you look at the whole thing, right, it's so wrong in so many different levels.
Yep, that sounds really familiar. And it's, yeah, I'm glad to hear that's, well, sort of glad to hear that it's not just happening in the United States. Yeah, I mean, I can't tell you how many like pitch decks I put together for VCs where the AI was, well, it's questionable whether it exists, but you know, it definitely existed in the deck because that was, you know, part of the pitch. It reminds me of that statistic that came out a year or two ago about somebody did a study of the artificial intelligence startups in the UK, and they found like 40% of these artificial intelligence startups were not doing anything at all with AI, but they were AI companies. So it's like, it's insane, but
Yeah.
there's a lot of hype. I think it's interesting. I don't know if it's just a bubble that we're in, but it seems like a lot of the hype is sort of, I wouldn't say dying down, but I think people are getting more realistic in their approaches. Again, this might just be, or you know, our group, but it seems to be the case. And meanwhile, there's some really cool stuff that's actually happening with real AI. You got GPT-3, which I mean is pretty cool. There's a lot of interesting stuff happening with edge AI and stuff, which I'm really fascinated by. Like that, I think could make that arms race that you kind of described. It'd be interesting what happens with edge, because that you know, kind of removes the need for the cloud in a lot of ways. And it's like, it's anyone's guess where this is going to go, but you know, I think it's awesome to still see, like, despite all the hype going on, there's still like people who are out there just making some awesome things happen.
Yeah, doing great stuff. Yeah, you're right. So there's a few things. So GPT-3 is of course another one of the interesting projects. I think that one is under open AI. And of course, we have like DeepMind doing all this, trying to move towards AGI. So they have all these like Alpha Star, Alpha Zero. Then there's also Fast AI as well. Jeremy Howard that's like coming out with all this. So I think Fast AI, I think Fast AI 2 came out already. I just shared a post on it. I haven't had a chance to look at it. I mean, yeah, you're right. I mean, there's a lot of interesting development. Once all these beginners, right, they have start to be able to demystify some of these myths and all this already, right? And there's a very whole new interesting world out there. I would say, and I love it. So the funny part was I didn't come from a comp science background. I didn't come from a comp science background. I came from, but I love mathematics a lot. But unfortunately, what happens is, I think back in the days when I was undergrad, so before college days, right, I was asking myself is that, hey, should I pursue my passion and study mathematics? But then I told myself, I said that no, because if I do that, right, because back then no such thing as data scientist or no. Yeah, so no. Probably what I'll do is I'll end up become a teacher. Now, having said that, I think Singapore teachers are much more fortunate than the public school teachers in the US. At least based on my reading of it.
I think anyone is more fortunate than teachers here, so it's pretty bad. Yeah.
So the thing is, I will probably end up as a maths teacher then. I mean, that's the only profession that's open up for people who major in mathematics. So long story short, I said that no, let's forget about it. So I took the one that has more prospects and still involve mathematics, and that was economics.
It's a great degree.
Economics. Yeah, it was actually, if you ask me, right, I haven't regret that decision of taking economics. I mean, I took economics in over here we call junior college, which is just before the college education. I took economics and I actually like that particular that subject a lot. And then after that, so I decided to pursue it in my undergrad years, and I haven't regretted that because whatever skills that I picked up during my study, right, was actually very useful now, even for data science or for
Oh yeah,
artificial intelligence. Yeah, I,
yeah,
mm, the one that was the key, right, was the analytical skills. It helps me to so the economics training actually helps me to be able to analyze things better. I'm not saying I'm very good at it, but I think analyze things better. And I think this is where data science comes into picture as well. So data science, um, I think a lot of people kind of felt that data science is more of the machine learning stuff, but I generally I don't think so. I think for those people who followed my posts and all this, right, I've already stressed before. I said that data science is more about getting value from data. It's not machine learning equals to data science or machine learning equals to artificial intelligence. I think more importantly is data science is about getting value from data, right? Uh, so at the end of the day, even an analysis is also a form of getting value from the data. That's like doing the descriptive and the diagnostic analytics the four levels of analytics that we are talking about. Yeah.
yeah. I tend to see that. I mean, I struggle a lot because with the term data science, I guess, right? Because when I look at the stuff that I had done back in the early 2000s, even from work, I have flashbacks because I realized, well, a lot of that same stuff is still going on today, and now it's called like data science. But back then it was, I mean, I don't know, you're just a number cruncher, I guess. Like I was called the numbers guy. They didn't even have a name. It's like you're just like this dork who sits in the corner and people ask you questions and then you give them answers. It wasn't a
Uh-huh.
glorified back then. I mean, similar to you, like I mean, I studied mathematics, and then the career options at the time was, oh, you can become an actuary. This was
Oh,
around very early 2000s, or you could go work at the NSA, or you could become an analyst. And I was like, well, I'll just become an analyst. And so I did
uh-huh.
that, and in a variety of different areas, operations, finance, and sales and marketing, and different areas. And I think that was a really good exposure to different areas of business and applying data to get real world results. And I mean, thankfully, I was in a position where the company was growing at such a fast clip that, like, um, you know, you had to learn really quick and how to,
Mm.
how to get data and how to use it effectively and so forth. So that was a great crash course in a lot of areas. But when I look at the challenges I had back then and the challenges now, it's 90+% of the time, it's um, people, it's asking the right questions, avoiding the wrong questions. And I think just, you know, adding value, as you say, right? I mean, that's the name of the game. If you aren't adding value, it's going to be incredibly tough for you to keep your
Yeah.
job. And you're seeing this right now, actually, with COVID and the, um, data science layoffs. And I think a lot of companies like pulling back on data science hiring because I think, from what I've seen at least, a lot of companies had hired teams of data scientists without really having a clear objective. It's sort of like the person who wanted you to do deep learning. It's like, well, if we get data scientists, magic will happen because obviously that's just how it goes. I read this in a magazine, so it must be true. And so they hire these people, and they're like, well, what the hell? Like, where all the magical things that I want? I don't see unicorns
Yeah.
anywhere. And so
Uh,
then slam the brakes in the economy, and you have to cut budgets, and things that aren't producing, they get thrown to the wayside. Unfortunately, I think that's what happened with quite a bit of data science, at least in the U.S. I know data science job postings recently were down like 41%.
oh,
Um,
okay.
yeah, that's job postings. I mean, the IT sector is still pretty secure, but I personally know quite a few data scientists who were laid off or
Mm-hmm.
had job offers rescinded, and that sucks.
Wow.
But so that's a lot of just latent brain power just sitting on the streets now doing nothing, which kind of
Okay.
isn't great. But at the same time, I think what happened was, again, it's just expectations were up here and
Mm-hmm.
reality was here, and that gap someday that gap is dealt with. So
Yeah, you're right. So over here we face the same thing as well. As in we did have like data scientists got retrenched and all. But what I saw was that most of them actually got rehired quite quickly. I think within
nice.
2 to 3 months. Yeah, from my observation. Um, but but the hiring over here actually has increased from what I noticed. The
Cool.
hiring actually has increased for data science role and all. But unfortunately, I think there's this myth that's going on, and that is I just have to hire a data scientist, and then I'll just throw him at the deep end of the pool, and he or she will be able to do everything. Which I think if you all know, that's that's not true. That's not true. I mean, data scientists can be your first hire, lah, right? I mean, data scientists can be your first hire. Not saying that it cannot be, but I think having said that, I think more importantly is for any companies, right, to even before hiring a data scientist, right, to start planning first. Okay, so people may tell me like, cool, you cannot you say start planning. That means I need to have some knowledge of what's happening, right? And then you say don't go out and hire someone. Then how am I supposed to what am I supposed to do then? Uh, if I were to do a shameless plug in here, you start looking for a consultant. Pay the consultant maybe for a day or two, right? So it could pay you, Joe. It could be paying me for maybe 1 or 2 days, and let us come down. We share with you what's really happening, what you can do to start off with, and then let's plan the roadmap together. Let's plan the roadmap together and says that, oh, okay, so this is what you do. Because the way I look at it, everyone's situation is very, very different. Some of them
Yep.
may have like data already. Uh, and one more thing is never ever take at face value, right? When someone tells you that their data is ready, never ever take that at face value. But
Yep.
having said that, so maybe we come back to the data thing in a while. So have a consultant come in, set up the roadmap and everything. Then look at the consultant should be able to look at what's existing on the ground, what kind of questions you'll be more interested in, and then after that plan out the whole thing. For all you know, maybe data scientist is not the first hire, but a data engineer should be coming in to do the first hire, as a first hire to hire the right people to come in and set up the data pipelines and all before you talk about machine learning, talk about machine learning and getting a data scientist and all this. And anyway, I kind of feel that a data scientist, unless you're in the big tech firms, otherwise for data scientists, you should have some analytical skills, some data
Definitely.
visualization skills. Yeah, because I, I guess I kind of understand why there's an impression that data scientist comes in, right? You do machine learning. Probably that will be painted by the big tech firms, but the way I look at it, right? If you're going to be hired not by the big tech firms, but by other firms, right, from other industries and all this as a data scientist, in any case, you have to learn a lot. You have to be a generalist first, rather. Data visualization, data management. Yeah, machine learning, yes, but I can safely say you won't be needing it for so soon, probably 3 or 4 years down the road, rather, depending on how fast the company matures. So anyway, coming back, so yeah, get a consultant to come in and set up the roadmap and everything, so that at least we can avoid mistakes in terms of hiring. But what I noticed is no, like I mentioned just now, right? They hire a data scientist in. The data scientist fresh from bootcamps probably only know machine learning, and then that's about it already, but don't know how to use the data to set up the whole what I call the data value chain.
Yep.
And because these companies, they heard that they have to pay the data scientists well, pay them six digit figures annually. in the US it's 6 digits, but over here in Singapore it's usually five, probably around the same, I guess, but definitely lesser than the US level from what I noticed.
Mm-hmm.
Uh, and then they start to distrust and say that, hey, I hired this data scientist come in, right? Cannot do anything at all of value, and I overpaid the guy. I mean, I'm not getting value back. I'm not getting value back. And then what they did was they said that, no, I'm so disappointed by the data science function. I think data science sucks. I don't want to do data science again. But if you look at it, right, the root of the problem has been, if you have planned, that money could have better spent and could have gotten value from the much more value from the data, right?
Mm-hmm.
If you look at it. So I will say, I think I'll advocate for any companies who are like just starting out and all this, right? Spend a bit of money and maybe get a consultant to plan the roadmap. Yeah.
Yeah, I totally agree. Yeah, sometimes the data needs to be addressed. That's like first and foremost. And I also urge companies, like once you get data pipelines set up, and for a lot of companies too, for your data pipelines, use something like pretty innocuous. Like there's open source tools you can use, like Meltano, for example, and Singer, and just get data flowing into something like Google BigQuery, which is like super cheap. Like get your data in there, and then once you get your data in, analyze it. Like it doesn't make any sense to do machine learning if you don't even know what the hell you're looking at in the data. Like you really need to understand what you're doing. Like I tell companies, like don't do machine learning until you have a very good idea of the data you have coming in. It's machine learning is, I think, useful once you have identified processes in your business that occur too quickly for a human to do, for example. Like that's a really good way to, good use case where you can automate things with ML. Or the data is so nuanced that it requires, an algorithm to really dig out the signal in the data. But analytics, I would say, is the first and foremost thing for most structured business data, right? Rows and columns. Make a data warehouse, for example, and get people using reports in your business. That's the other thing I see companies making a big mistake on, is that they don't get widespread adoption of the data itself, and yet you expect this data scientist to come in here and just magically elevate your company into, a FANG stock or something. That's freaking crazy. But it takes time, and it also takes that data scientist you hire should, ideally be a leader for data and getting adoption of the data throughout the company in the form of reports. It should be such that if somebody's not getting the data they need, they're going to yell and scream about the fact they haven't gotten the data. And then ruthlessly cull reports too, and data. Like my old trick was I would just stop sending out reports at random to people, and I would see who would scream. And if nobody cared, then I was like, well, okay, I guess I don't need to send this out anymore, and we can work on other stuff. But it's definitely, the data scientist definitely, especially early on, needs to be definitely needs to be the role model and the leader for that initiative in the organization. I mean, you're hired, I think, for your skills, but ideally you should be hired as much as to kind of spread the gospel, so to speak, of data throughout the organization, because that's how you're ultimately going to win. And I would say that's ultimately how you're going to be able to get the political capital in a company to hire more data scientists and start doing machine learning. But if you're just doing machine learning on itself, it just, without having an understanding of your data, you're just doing dumb things faster, and that doesn't really help you at all. Like that's just stupid. So you shouldn't do that.
But you're right though. So the problem gets compounded, right, when you hire someone who is just fresh from a bootcamp or a degree, and you expect them to play an education role as well in the company, when they themselves already just started on the field. They themselves also trying to figure out what's happening on the field, and what maybe even compound the problem, even make it more worse, right, is the trainer for the bootcamp, the trainer for the degree programs, the instructor, the faculty for the degree programs, and all this. If they don't have the actual working experience and all, right, what's going to happen is whatever they share is very theoretical. And it's not something that maybe the best practices, it may not be the best practices and all. Okay, I'm not saying that those people who are experienced can share those as well. But I'm just saying that I think the probability of it is actually much higher. And it gets compounded. So the trainer maybe just a quarter of the glass full, not much water to give, not much water to give to the beginners with in the first place. And the beginners only have that limited amount of water to work with. And now they're going to like pass that water down to the next level, which is like trying to educate the stakeholders. So the whole thing becomes, how to put it? But so when it flows, because there's not much being shown, being fed down the levels, right? That's where a lot of people gets a lot of misunderstanding, a lot of hey, is this true? And they start asking questions. And now normally the questions, they pose this question to who? They pose this question back to the universities. They pose this question back to the bootcamps instructors. They'll pose this question back to software vendors. Now, if I were software vendors, I don't fault them. I will definitely craft my message so that when you ask me this question, I get you to buy my services. I mean, if I were them, this is what I'll do. Also, you can't blame them. I think so. So the solution to it, right, is actually education, like what I mentioned, less ignorance, and I think also more critical in like, you have to ask yourself this question that, hey, when you're asking this question to a particular person, right, would he or she have a personal agenda to sort of massage the message so much so that you will so you may fall into what he or she is trying to achieve.
This is a really good point, actually. I think maybe with the high, if it's your first data science hire, I would probably say don't hire a person from a boot camp. And the reason is, if you're going to make an investment, make an investment. But you got to put your money where your mouth is. And it's like you wouldn't hire, like, you know, unless you're going to have a system in place to support this very junior hire, and be very accepting of the fact they will make mistakes because they don't know the questions to ask, and they're going to be learning on your dime a lot. You know, it's a good 2-year ramp up for a junior person to become, I would say, competent at like a mid-level position, right? I mean, that's just kind of how it is. So if you hire somebody who's just like fresh out of a boot camp and expect them to like create your entire data science program from scratch, that's insane. But go for it if you want, I guess. Just be patient, though. You know, and strange things have happened. You know, I mean, it's you know, but I would say, you know, at least the hiring manager definitely needs to get educated in terms of the roadmap, and that's where a consultant could come in, or if or if this hiring manager is inclined to just read and you know, better understand this themselves, more power to them. Or if they want to hire somebody who's very senior to come in and help at least establish the new data science you know, department, or whatever you want to call it, like that's also, I think, a very good approach. You know, because the junior people are going to need mentorship. That's just how it is.
You're right. Yeah.
So it's insane to you know, and, you know, unless this person from a boot camp is like some crazy savant who is like really good at managing, really good at public relations, like really good at like navigating political stuff in a company, and can still do data science, like that person is pretty much going to be the CEO of the company in 5 years anyway. So just for, you know, but it's like, because this person's very gifted, right? Like that's a very rare person. But it's a tough one. But I would say that the hiring manager definitely needs to have a plan in place for sure. I think to your point, right? That sometimes comes from outside perspectives. The most successful teams we've seen are the ones that take a very agile approach. They learn, they iterate. They're not afraid to make mistakes. They obviously don't try and make a lot of mistakes and make the same mistakes twice, but they understand mistakes are going to happen. It's part of the game. So as long as you can keep moving forward towards your objectives, and that's, you know, maybe the best place to be. But agile is it's easy to talk about. I think it's really hard to do just because people are people. So You see the same thing in software engineering as well. It's like everyone wants to do
Mhm.
agile, and then still it's like the failure rates of IT projects and software projects is the same as
Mm.
data projects. It's 80+%. So I think at that point you got to step back and because I'm actually going to have a talk about this on Friday about
Uh-huh.
why data projects fail, and I start thinking about it like, well, like what is it that makes data unique against any other paradigm? And there are some nuances, and there's a lot of similarities. So there's people,
Mm.
but data, you kind of hit on this too just a second ago, where data is an interesting thing because you can get people sort of massaging numbers. Um, data can be weaponized. I think that's maybe one of the big differences in companies is that depending on people's agendas and how political it is, data can be used in reports that compete against other reports, and then you have this, and that sucks. So.
You're right. But I think at the end of the day, I mean, even for people who consume data, right? I think it would be good to have this idea about the background and the possible agenda of the person who's presenting the
Mm,
data. Yeah, I think that's something that is overlooked in a lot of companies. But to be fair, we are in an era now where we have a lot of data to work with. And data literacy is something that is not well taught in the first place. I mean, this is something new. This is a new exposure and all. So data literacy is probably something that is needed now. But how do we get that into the minds of the people? I think that's where we need probably the education ministry to come in and share and all this. The closest that we have is what? The closest that we have is visual literacy, which is knowing how to read the graphs and all. But let's face it, I mean, at least based on what I remember from my primary school days or my secondary school days, sort of like the grade 1 to grade 6, probably in the US and all, we only probably learn how to read graphs like pie charts, bar
mm.
charts. I don't remember scatter plot as well. We're not taught to understand scatter plots, but I think pie charts and bar charts, these are the two. But now once you're like now at this stage, so I teach a bit of visualization in my classes as well. You start to realize that pie charts doesn't work anymore. I can't remember who was the one who mentioned this. Pie charts is really one of the worst visualization to be used.
It might have been
Uh,
me. I don't know. I hate pie
is
charts.
it?
So,
Okay. No, yeah, I get I can understand why pie charts is not that great. Okay, so if you look at pie charts, right, at the end of the day, we're not a being that knows how to compare angles. Put it that way.
right.
We are yeah, and angles is being used over in pie charts to represent numbers, to encode numbers, or what we call uh, visual cues. We
Hmm.
use angles as a visual cue for pie charts, and we are not very good with comparing angles anyway. Uh, so, but unfortunately, I think back then in the older days, like the primary schools and the secondary schools, we were taught to read those charts, and then everyone gets so used to it, so comfortable with it, they did not, so they can't get away from it. Put it that way, and this is where uh, a lot of charts that you see right now has all these pie charts lah, bar charts as a normal. And it gets worse. It gets worse if the data scientist is trained in visualization, so not so bad. But if the data scientist is also not trained in visualization, which is actually
Hmm.
lacking in most of the bootcamps that I noticed as well, it gets very boring, no? I mean, if I even for me, right, if you ask me keep on looking at bar charts, line charts, and pie charts, right, that's it's boring is one, you won't get my attention. That's one. Second thing is also I think that there's very limited insights you can get from all these normal common charts as well. Uh, and again, if you look at it, right, going back to the point that we were discussing about, even visual literacy is also very limited. Uh,
Yeah, I
so
agree.
so yeah, I just hope that for any ministry of any education ministry or education minister who really wants their population to be a bit more savvy when it comes to data, I think data literacy and the visual literacy has to be built up further.
I totally
built up further.
agree.
Yeah.
Yeah, I mean, our mutual friend Dave Langer, he has a really good approach to data literacy in companies, not for school, but he's teaching people data literacy using Excel. I think that's really cool. At first, I
Yeah.
thought, wow, that's interesting. But then he explained it. Look, I mean, there's 750 million Excel users around the world. So the chance of them learning R is probably a big fat zero, like they aren't going to. They don't have time, but they have Excel in front of them, so let's use that. I'm like, that's actually brilliant. That's a really good idea. And then he walked me through, you know, in a meetup actually that we did with him a couple months ago, some ways that he was doing this data literacy training. I think that's absolutely brilliant. Then it's a gateway drug to other, you know, other things. But you got to start somewhere. And Excel, I think, is as good of a place to start as any, because the amount of data literacy in companies that I see, it's across the board. Some companies are fantastic at data literacy, and everyone's amazing. And those companies are making, you know, tremendous progress, both as companies and because you're able to utilize the data and you know, and I think build the business off of that, and then contrast that with companies that are barely able to use Excel at all. And I mean, I don't know where they're going to be in a few years. I mean, you might be lucky, actually. I mean, maybe you're just like, I don't know, what would you be selling N95 masks or something for the next few years? Like, you probably don't need to be too sophisticated. You just need to make them and sell them, right? But that's, but that other businesses probably a bit different. So yeah, data literacy, I
Yeah.
totally agree with that. And
Yeah.
it's easy.
Right. So
It's easy to lie with numbers too in companies. Well, I wouldn't say lie maliciously, but in the sense where data is, it's a silent killer. Like, you may have issues with your data and you may not know it for a while. Actually, you may be making decisions off of wrong numbers. This happens quite a bit, actually. Like,
yeah.
what was it? Some stat, even I think Harvard Business Reviews talked about most Excel reports, like 80% of Excel documents have some sort of an error in them. So
Oh, okay.
yeah,
Well, I
small
mean,
issue.
okay, yeah. To that point, right? What I say is, I think it's more of like trying to reduce the ignorance, trying to increase that data literacy. I mean, you look at it, right? If just maybe look at this point over here. If you go to a particular country, okay, and you know that, and when you're prepared for any scams or for any crime that is going to be happen over there, right? And as more and more people gets prepared for it, right? These like scammers lah, pickpocketers and all these, they'll start to realize that, hey, it's not going to be easy to make a living, right? And what they'll do is they'll change. So in a similar sense, it's like as more and more people gets trained in data, understand how data works and all this, being able to ask the critical question and all, I think all these different sort of data mistake, whether intentional or not or unintentional, right, would be rooted out as long as
Yep.
more and more people gets to understand how data work. And I think so to that point, right, it's more of, I think there's two sides to the coin. As analysts, as a data scientist, we try to reduce the intentional mistakes. We try to remove the intentional mistakes. But I think on the flip side, the audiences, the stakeholders, and all this probably also need to be more educated in how data works. Yeah, and I think that will sort of help each other to improve along the ways. Yeah.
Yeah, I think that's going to go make a big dent, and I think a lot of the
Yes.
problems we see. So
Yeah,
that's awesome.
exactly. Yeah. Oh, talking about the Excel part, right? I think a lot of people also have this understanding that, I'll call this myth, right? That doing Excel is not data science and all. Yeah, put that in one of the put it in one of my LinkedIn posts and all. So I kind of feel that, I think, was it you or was it someone else that says that, I think people who mention that are just people who are, how put it, condescending folks. I don't know whether was it you, or I think someone else was posting about this.
Might have been me, yeah.
Uh,
I say
but
things like that, but yeah.
yeah, but I think for the audiences who are watching this, I just want to stress here and say that I don't believe in that. I'm pretty sure Joe, you also don't as well. I think at the end of the day, if you go back to the definition of my at least my definition of what data science is, being able to generate value from data. To be honest, I really don't care about the tools. I don't care whether you're using R, Python, Excel, GCP, AWS, or whatever.
Yeah.
I think more important is that you can generate value. And I think what Excel provides, right? Because Excel is ubiquitous in the first place, right? I mean, everyone has it. Everyone has some knowledge of Excel and all this. And like just on what you mentioned, but I think David Langer was showing using Excel as a tool and all. I think it's a pretty good tool to increase the data literacy level because everyone knows how to use Excel in the first place. I won't say everyone. I think most people, I'll put it that way, because I did come across a group of people who are not that familiar with Excel. But that's a topic for another day. Uh, and since it's ubiquitous, most people know how to use it. I think it's really a good tool to start off with first. Like what you mentioned just now, to start off, you understand the data first, understand what you can do with the data, and then from there you move on. But having said that, I kind of hold the viewpoint that yes, Excel is a good start, but I think sooner or later, if the company were to mature in using data and all this, right, you probably will have to move to scripting language, language that you can do scripting with. So probably like maybe Python, R, and all this, because you probably will start thinking about automation, like how do you automate the ETL process so that you can feed the data into maybe your dashboard or reports and all this, right?
Mm-hmm.
I mean, Excel, yes, to a certain extent, yeah, but I think once you get to that point where you want to do automation, or probably Excel may not be the right tool to automate. But I might be wrong. I might be wrong over here. But subsequent, so my viewpoint has been yes, you start off with Excel first, something that more people are familiar with. Then after that, you probably have to move on to the other scripting languages to do up
Well, yeah.
your
I mean, you talk about
automation.
this quite a bit. It's not really, the tool per se. It's like, what you're trying to do with it, right? So,
Yeah.
yeah, I think it is interesting. I mean, I think it's becoming less and less now, but I did notice over the years, data scientists having like a superiority complex about Excel. Like, well, if you're using an Excel, you're obviously an inferior data person and probably an inferior human being in general, just because you're using Excel. So it's like, I mean, it was just derided as just this utter waste of time. But actually, some of the best data people I know are like financial quants who can use all the shortcuts in Excel, and they're absolutely brilliant at what they do. And they're getting a lot of value out of their data. They're making a lot of money off the data, for one, right? So, I mean, I wouldn't be sitting there talking, like smack talking these guys that could run circles around you any day of the
No.
week. So, and if you give them R or Python, I'm pretty sure if they figured it out, they could do, a fantastic job with that. But it's just context switching. If you're really good at the tool you have and you're making money on it, like, I guess, and it works. Sure, and that was true up to a point. I think now though, as data grows, like Excel's probably not going to be the best option, or if you're dealing with terabytes or petabytes of data. I mean, it's interesting though, because it's like we do a lot of work with Google, and I think Excel's doing the same thing. But like Google's BigQuery works with Google Sheets. You're actually able to use Google Sheets and query massive amounts of data in BigQuery. Like that's pretty cool, actually. But I think Google realized that the spreadsheet is such a ubiquitous front end for data people that you're not going to get away from spreadsheets. So you may as well figure out how you're going to incorporate the back end, a big data warehouse into that. And that's pretty cool. And I think you're going to start seeing more of that. It kind of reminds me of the arguments against SQL back in the day too. Like I think the early 2010s, everyone's like, oh, SQL's dead, because we got all these, NoSQL databases out there, and they're obviously going to take over the world. And nobody's going to write SQL in 10 years. And it's been kind of funny. And I may have been one of those people back then that's like, well, yeah, I mean, why would you want to use SQL when you could just write everything in, this really cool database that, and yeah, no, there's certain cockroaches in the data landscape. It's Excel and SQL, I think are the big ones. And then there's this, Bash is the other one that's not going anywhere. And so I've seen too many people try and replace SQL and Excel over the years. And it just ain't going to happen. It's not happening.
No, yeah,
So,
I don't think so though. For SQL, right? I actually I actually do self-learning for SQL. I kind of like SQL because the language. So what I share with participants, right, when they ask me about SQL is I kind of feel that SQL is very close to English language.
mhm.
I mean, for those people who have come across all the maybe the older programming languages, right? You probably see that, hey, I still don't understand what's going on because of the syntax and all. But I think SQL is one of the languages, like I won't call it a programming language, a Korean language perhaps. Where it's so close to English, I can't find another language, right, that is so close to English. I mean, if you look at it, select, from, where, order by, group by. I mean, these are the simple clauses and all. And how can you make it easier? I really do not know. I really don't know
Right.
how can you make it easier really. And I'm so amazed by it when I started learning SQL and all, because of the clauses. I looking at the clauses and I was like, wow, this is so friendly to, I think, to a lot of people. And we should, or at least for me, I should encourage more people to do SQL. Yeah, the reason is because, like, so I have, so during my classes, right, I have people coming to me and say, hey, cool, you know what, I think my data analyst is overwhelmed, my data scientist is overwhelmed, but I like to get some numbers crunched and all this. So I told them, I said that, hey, if your company is using like RDBMS, so it could be maybe MySQL, Postgres, and all, right. So why not pick up SQL and query the database and get your numbers immediately? Then, if that's the case, then you don't have to wait for your data analyst and data scientist. Then they said, no, programming, I'm not that comfortable. I said, no, you should not be thinking that way. I think for us, I think most of us now, right, how we learn programming these days is we have two I tell people we have two tools, right, that is very important now to learn programming, and it's free. And these tools are free. It's more like whether you're going to put in your time and effort into it. And one is Google, the other one is cut and paste. Of course, I'm trivializing a bit, oversimplifying a bit here, but I think to encourage the beginners to start off with, right, it's really you just remember the two tools. Right? You just have to do Google. You just have to do copy and paste. But of course, we all know that yes, you copy and paste. I mean, okay, generally, I think most of us will copy and paste from Stack Overflow. I think that's a predominantly
Yeah.
that's the website that we copy and paste from. But then you copy and paste. Of course, you also need to understand what the code is talking about, because you have to sort of still change it, right? You still have to change it, change the codes a bit to suit what you're doing and all, and then you have to do some testing and all this. And I told the folks, so the folks will say that, hey, cool, no, you know what? Yeah, I tried my hands on it before, but the error message, I still don't understand what's the error message. I tell them, I say, I have never understand the error message at all, because I'm not from a comp science background anyway. And I never studied programming language. I never studied compilers and all this. So all these error message are very cryptic to me. But I told them, I said that, you know what? Google will know more than you. So just copy and paste the error message into Google, and let Google figure out for you. Yeah. So the solution should also appear as well. So if you look at it, really, I mean, not to trivialize learning programming, but I think as a start, right, the two tools of like Google, being able to use Google and being able to do the copy and paste, I think it really helps a lot, right?
It really
For
helps.
programming.
I think
Yeah.
the advice I give to people learning new languages too, or I should say a new language,
Mm-hmm.
probably starting out with one, um, like master that language, like, go become an expert in that. I don't recommend, well, I see people, and I'm guilty of this myself, like, sort of, shotgunning, a bunch of different languages and just trying to, learn everything. And a long time ago, I took a step back and I was like, well, let's just, let's get really good at something, And so for me, that was Python.
Uh,
This is actually one of the first languages I started with back in the day too, but I liked Python a lot, but I vowed, well, okay, I'm gonna really understand it. So I read the documentation on Python. I'm a really
oh,
exciting guy apparently. And for the packages that I would like pandas or any of the packages, Django. I was actually writing a lot of web applications at the time. I would dig into the source code, so go on GitHub and actually like look
oh,
at the code that does what you're doing. And I think that serves two purposes. One, reading other people's code helps you become a better coder, and two,
mm,
when you start seeing error messages, you really understand why now because you've actually looked through the source code and you understand, okay, so this is actually how it works.
okay.
And I think by doing that exercise also, you learn issues like potholes to avoid,
Mm-hmm.
potentially. uh, so those are the approaches that I suggest as well. As you start getting more comfortable in the language that you've chosen to learn, say Python, like, the documentation for Python is awesome. Like, just go read it. Take your time because it's very
Yeah.
dense, but
Yes.
there's a lot you can learn in Python. And there's I remember even like Guido van Rossum, the guy who wrote Python, when he
Mm,
asked, somebody asked him like, so I think he was at Google, and they're like, well, do you think you could, pass the Python interview questions or something? He's like, probably not. He's the guy who was like in charge of Python.
yeah.
So,
Uh,
it always take a beginner's mind in that respect. And I still take the time, I'm, running a company now. I'm a bit out of coding, it's not as much as I used to, and that's perfectly fine, but I still take the time to go back and revisit,
yeah.
aspects of even the standard library in Python, just to, just for fun, I guess. Just also look at new changes too, like Python 3.9 is coming out really, really soon, and that's going to be pretty cool. And
Yeah.
just staying on current. But yeah, yeah, I like your advice. Like, it's awesome. You can just Google everything, copy and paste. And I would say once you get that down, and you want to dig deeper, there's no end to it. Just keep digging. So it's
Yeah, I think what to be fair, whatever I propose, right, is only for for beginners lah. I think
yeah, yeah, for
after
sure.
a
Yeah.
while, yeah, after a while, one have to realize that there are other things involved when it comes to programming. So, like for instance, knowing how to do comments, how do you comment your codes, uh, and a lot. I think there's one misconception that people have when it comes to programming is that it's straight through, right? It's straight through. But I think if for someone who has been doing programming for a while, you start to realize that actually no, it's more of like there are many roads to Rome,
Oh, it's like
right? Then yeah,
it's
exactly.
everywhere.
Yeah, you can like this is A and this is B, and then everyone's like, yeah, there's many ways to reach from A to B. You start to realize that, and then what happens comes, what matters the most then will be whether you have that sense of, hey, if I choose this route, what are the resources I conserve, but what are the resources that I'll be using, and is that suitable for the certain circumstances that we are in, and all this. So
Hmm.
that's where I think one will know that you are sort of at the more intermediate to advanced level already when it comes to that kind of consideration during the programming stage.
Oh yeah. There's good books too, like The Pragmatic Programmer is a book I'd recommend anyone who's been writing code for a while. That's
Uh,
a must read.
mm,
Um, because at a certain point, the criticism I have with data scientists, is a lot of them can't really code that well, to put it pretty bluntly. Like, they can code to the extent that it'll do what they need to do, but if you're on a team, like, maybe take the time to learn, principles of software engineering, and maybe even, like, at a certain point, if you're so inclined, study, principles out of computer science and stuff. I think it'll just make you a better data scientist when you can really understand that, like, how memory works, how code affects, memory and IO and everything else. Like that's pretty cool, especially when you're dealing with data. You're going to run into issues with that at some point. So knowing how to diagnose those problems is really key. And also knowing like what tools are going to be best to solve your problem. Python's great, but at some point, I can make a pretty strong argument that it might not be the best tool for a lot of stuff, especially when you're getting into like the software engineering end of things now. Like there's like Python's global interpreter lock, for example, that couldn't cause you problems if you're trying to do a lot of parallel stuff. So, but it's a long journey, and you got to take the time, and I would say patience is probably the biggest attribute I would recommend to data scientists or people in general, just because everything's going to take you 10 times longer than you think it does. So
yeah, so that's why I think the other thing is also because there's a lot of things that we need to learn as well during our work. And also, I think programming is one of them. I also agree with you. I think most data scientists I come across are poor programmers, including me. We just do it enough. We probably just do it enough. That's why we probably need a data engineer or a machine learning engineer to come in and sort of improve upon the codes for production and all. So sorry, which point was we were talking about just okay. So I suddenly just lost in thoughts because of the. Yeah, let's see. I'm trying to. Okay. Anyway, so I suddenly have these kind of moments where I suddenly got lost in. Yeah. What we were talking about just now? Data engineers.
Like learning and coding and all that stuff. Yeah.
So we actually have to know a lot of things, especially let's say if you're the only probably data scientist in the company. So you probably have to learn about visualization. You have to learn about how they do data management. In fact I advocate so for data scientists, right? I advocate that you do a pyramid shaped learning. So that's it. So when I say pyramid shaped learning means that you have to learn everything, right? And then depending on where you choose to go deeper in, right? You sort of form the pyramids this way in terms of the expertise. Yeah. So if you plot the vertical axis as expertise and then the horizontal axis as a breadth in terms of the skills and all this, I think every data scientist at least I would say you should learn sort of like a pyramid shape. You should learn as a pyramid shape. And so in fact, there are some people who also say that, hey, when it comes to data science learning and all this, you should have a T-shape. I think I can't remember who was the one who said that. So you should have a T-shape. And some of them were saying that you should have a pie shape. That means you have two depths, two areas of depth and all this. But the more I look at it, for me, I kind of feel it's better to have a pyramid. So whether a pyramid sort of have or maybe don't call it pyramid, maybe a parallelogram. So where you have a longer top and a shorter bottom. Yeah, so the learning also, so if you look at it, I think data scientists are always learning. If you look at it. And I kind of feel that if you want to know whether a person is really learning about data science and all this, right, whether he's really working in the field, you probably can, through the tone that you're talking, when you're talking about learning and all this, right, you can roughly have some idea, because I kind of feel that the good data scientists generally have this imposter syndrome, something that some of them were discussing about on LinkedIn, and that is like we kind of feel that, hey, we should not be in that field, but because there's so much to learn, right? There's so much to learn. We don't feel that we never feel that we're adequate, put it that way.
I totally understand what you're saying. Like you don't feel like you're ever good enough. Like there's always something you have to, one more thing you got to learn, right?
Yeah.
Yeah. I suffer through this a lot. It's like, somehow it's never enough. You feel inadequate, and it pushes you to keep learning, right?
Yeah, exactly. So I kind of feel so when I talk to people, right, and if I hear someone who says that, oh, I'm a data scientist, I know everything already. I said, yeah, I think this guy better stay away from that
Yeah.
such a person then. Yeah. Because this guy doesn't really know data science then, if that's the case. I rather be with people who have that imposter syndrome and say, no, I don't know everything, but I'm willing to share. I think
Hmm.
that last statement is the most important, because they know that they don't know everything. So they know that even when they share, right, it's not like keeping trade secrets. It's not like keeping
Right.
trade secrets. It's more of like sharing. Let's share some of the best practices so that everyone can sort of improve
Yeah,
together.
it's a fixed mindset versus a growth mindset, right?
Yeah,
Like,
exactly.
and yeah, and something like data science, it's not like this is a zero-sum game. It's not like if you know something, then I somehow don't know that. Like that, it doesn't work that way, right?
Mm,
Like
mm,
knowledge compounds on itself, and
yeah,
that's one reason I like the group we've somehow managed to put together in LinkedIn, because everybody benefits from the knowledge that they share.
yeah.
And there's different opinions. I think this is great because the worst thing that could happen is if all of us didn't talk to each other and just felt like, well, I
Mm,
already know everything and I already have all the great friends in the world I need. So we'll just, not meet any new people and not learn anything new. It's like, I don't know, to us, it just seems like beyond reason why you would want to approach things like that. I'm sure there are people that are like that, but the people who get ahead in life are the ones who are constantly pushing themselves and learning
mm.
and reading. Like my weekends are spent, this iPad has like usually anywhere from 50 to 100 articles on it. And
Okay.
I read all of them and,
Uh-huh.
books all the time. So it's like,
That's a
it's,
lot, no? That's a lot of content, no? I'm struggling. If you ask me, I'm struggling with content these days. So 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 you read articles, right? So for me, I have books. I got audiobooks.
mhm.
I got podcasts. I got magazine journals and all. Yeah. So these are contents that I'm trying to digest. I'll put it as struggling to digest and all, because there's so much to learn. So like even so for me, like my learning, right? I got ebooks. I got physical books. And so over here in Singapore, we are bilingual. We learn our mother tongue. We learn our mother tongue and also the English language. So I also read books read Chinese books as well. That's
Oh,
how I
wow.
sort of keep track. Yeah, that's sort of how I keep track on what's happening on the AI front in China as well.
Mm.
Uh, so you can see there's really a lot of content to digest over here. So I think to touch on the point would be more. I think most data scientists would have that kind of struggle. I kind of feel, and I think one skill that it would be really good is being able to learn efficiently. Right, being able to learn
Yeah.
efficiently. How do you pick up all these different things, and how
I,
I think picking up is one. Probably application will be another. Yeah.
I think like learning the basics is a really good place to start too. Like again,
Mm,
the student I was talking to today he kind of asked, "So what should I go study?" And I was like, "Well, I think you should go study the fundamentals in grad school, like the stuff that underlies everything,
mm,
stuff that's not going to change over time, like math and statistics. Like if you have a really good understanding of how that works and can apply it to machine learning, for example, or whatever other field like that, if you understand the fundamentals, like that gives you a huge leg up. Same thing in computer science. Like if you understand like the basics of computer science, like big O notation, for example,
yeah.
or any number of other things, like that gives you, those aren't going to change, and you can keep building on that foundation there. And same with
Mm,
machine learning. There's certain fundamentals. Um, you know, there's statistics, linear algebra, calculus, some probability. It's a shit ton of stuff to learn, obviously,
yeah.
but you have to start somewhere. I mean, and
Yes.
thankfully, a lot of these frameworks have sort of obfuscated having to learn all that stuff because that's a lot of stuff to learn. Linear algebra
Mm-hmm.
is a pretty difficult subject actually to learn,
Yeah.
but I would say like, if you could somehow find the time to understand the underlying principles of the tools you're using, the underlying math, especially. Like I think that's a good investment for a data scientist, because then you approach your problems a lot differently. Like you're able to dissect, okay, so this is how it's working, and from first principles, like this is, um, this algorithm might work better for this
Yeah.
reason,
Mm.
right? And so it just gives you a different perspective. But again, there's endless roads you can go down, and I think, as you say, learn efficiently, because there's no shortage of information in this world right now. There's actually way too much. So
Yeah, so you touch on another point I think is very important here, and that is the mathematics. Is good to understand the mathematics behind. I think also a lot of people have this question as, hey, cool, you mentioned that, yes, I need to learn mathematics for data science and all this. Yes, I understand what you're saying over here. Yes, we need maths and all, but so what are the fields? I mean, maths is so wide, right? It's such a wide subject on its own and all this. So what should I pick up then? And right, I think linear algebra is one of the topics that regard it might be heavy, but I think at the end of the day, is needed, right? Linear algebra is something that that the one needs for for data science. Then after that, there's also calculus as well. So generally, I advocate that anyone who wants to start with data science, go with the mathematics first, go with the linear algebra, go with the calculus. Then of course you can't run away from the statistics as well. These are the sort of the three branches. Should I call statistics as one of the branches for mathematics? I probably will get slaughtered by a statistician, but yeah, but those are the three, I would say, the three areas that one should touch on if they want to understand a bit more about what data science entails.
I would say too, just for data literacy, just kind of circle it back, like having a good, even a basic understanding of statistics really helps.
Mm-hmm.
I mean, statistics comes up every single day, and all facets of news and work and everything else. I think just having a good understanding of how stats works. Again, you don't have to get too complicated, but just understanding even like what are the different types of an average, for example, and then when would you use them? Like that's, I mean, you're not going to take an, um, you're not going to take like a mean of people's incomes, right? But that's a standard thing. It's a standard malpractice you see a lot in companies, where people just say, "Oh, well, here's the average income." It's like, was that a median, or is that like the mean, or like which one are you talking about, right? So just having understanding like what to use there is even pretty key. So yeah,
Yeah, the mathematics and all. So sometimes like you're right on like the different means and all this. Yeah, I probably have a lot of people now wondering, hey, really? There are a lot of different means. Yes, if you actually do go to Wikipedia and have a look, there are a few different means altogether. How we calculate the means. Then the other thing was, talking about that, so like I said, I'm quite fascinated with mathematics and all, right? So so I started to study algorithms a few years ago. And again, like I said, I didn't come from a comp science background, right? So what happened was I was quite amazed by the different types of sorting algorithms. So I didn't think of that. I wasn't thinking of that until I realized that, yeah, when you're looking at computers, you're using computers and all this, right? There's this thing called computation complexity, right? Where you now have all these different notation. I think it's the O2 notation, the how fast the formula will be done, and then you now touch on other things like whether P equals to MP. That I can't remember what's the name. That conjecture. That's where I realized, hey, actually algorithms also is a very interesting area to study because of the constraint, the limitation. So because just look at sorting itself, right? I think there are like 15 over 20 over different algorithms just to do sorting alone. I mean,
oh, easily,
yeah, it's correct.
there's a lot.
Yeah, exactly. Then that I think to some people may say that, yeah, sorting is sorting. Why need so much algorithms? But I was quite fascinated by it because of all the different ways of sorting, and it also shows like how people look at things, look at a single problem, and there's like many roads to Rome, which I think goes back to the point about doing the data science project, where data science project, yes, that's an A to B, but there's so many ways of like traveling around just to reach that point B. And so in order to be able to understand all these different roads, right, this is where learning comes into picture. We have to learn. The more we learn, the more we can know what are the different paths that we can take from A to B in the data science project. Which
Totally.
Yeah, I kind of like the aspect. I like the aspect where the more you learn, there's a certain feedback from the project that tells you that, hey, yeah, you're doing well, or no, you're not doing that well. The project that says you're not doing that well, go and learn some XXX or YYY, and then you have that opportunity to know where you can improve on. So that's one aspect of data science that I really love, where I can continue learning and also get feedback on the learning quite fast,
Right.
from the project. Yeah,
That's awesome. Well, cool. Well, I think
yes,
this might be a good place to stop chatting for a while. So you look forward to seeing you on LinkedIn soon. And yeah, let's have a chat again in a month or two. I enjoyed talking with you.
Oh yeah, the pleasure is mine as well.
Yeah, awesome.
Well,
cool.
There's still a lot of things to cover though. Yeah.
Way too many.